Stereo from shading. Videos marked with the anaglyph icon can be watched in 3D using anaglyph glasses, red on the left eye, blue on the right. In 1989, a paper called The Power of Shadows, Shadow Stereopsis was published by Antonio Medina Puerta. It claimed that two photographs taken from the same position but with varying lighting could provide a convincing stereoscopic 3D sensation, presenting this image as evidence. Inspired by this work, we propose a new method for stereoscopic 3D rendering called shading stereo. Let's do a quick overview. This is a traditional stereo setup. The cameras are shifted along the camera axis, creating a 3D sensation when the images are viewed stereoscopically. Previous work proposes leaving the cameras static when creating stereoscopic views, but shifting a light source along the camera axis instead. Intuitively, we see that images generated this way can match the regular disparity scenario for a round object. We started thinking about how to apply this idea to the world of computer graphics. However, this approach is clearly not generalizable. Moving lights even a little between eye renders can create huge differences in cast shadows and specularities, making the scene impossible to fuse. It's also not clear how to generalize this idea to arbitrary lighting. Our first proposition is to change the original idea and instead change the lighting for shading only. Keeping specularity and cast shadows natural helps avoid disturbing 3D. We adjust the normals of objects in the scene between eye renderings, which allows arbitrary lighting and complex scenes to be handled, while automatically keeping cast shadows static. We call our method shading stereo. Note how the stereo images with normals adjusted between the two renders cause a subtle change in shading that generates a stereoscopic 3D sensation. We explored the feasibility of shading stereo in a user study. Participants stereoscopically viewed the 5 shapes shown here under various conditions, and selected 3 measures to characterize perceptually acceptable limits for shading stereo. Some results of our method can be seen here. The left and right eye renders are shown on the top, and a visualization of the difference between the two below, with the common colors symbolizing no difference, darker regions showing left to right differences, and lighter regions showing right to left differences. Feel free to pause the video to look at the 3D detail. These and other results are available in the supplementary material for different shading stereo and disparity settings. We would like to stress that anaglyph is not the ideal medium to appreciate shading stereo. Separate views for all these results are provided in the supplementary material, and we strongly recommend that you look at the results in color-neutral 3D. This skull is illuminated by an environment map. Relighting live-action scenes to augment them with shading stereo is also possible. See the paper for more information. Shading stereo is also directly applicable to videos. These elephants are illuminated by multiple lights. Several bright lamps are present in this sumo fighter scene. Finally, this live-action result is generated using a precise geometric scan of a man's face. Thank you for your attention.